we have algebra 2 problem. Okay, there is an equation given over here, that is I times x to the third power positive 2x square positive 1 equals to 0. If I is one root of the above equation, find the other roots. Actually here we have a cubic equation, that is equation of degree 3. So the largest exponent of the variable x in the equation is 3. So this equation usually will have 3 roots, and one of the roots is given, that is I, and we have to find the other roots. And already we know that I is an imaginary number, and we know that I square, the value of I square is -1. Okay, now what I'm going to do is to get the remaining 2 roots of this equation. So I'm going to reduce the given cubic equation to quadratic equation, that is the equation of degree 2, using the given root I. So how can we reduce this cubic equation to quadratic equation using the given root? For that we can use synthetic division. Okay, let me draw. Okay, so here inside the synthetic division, I have to write the coefficients of the variables, including the constant term of the expression I have in the given equation. The coefficient of x cube is I. So and the coefficient of x square is 2. Actually, the x term is missing. Usually, when we have a cubic equation, the first term has to be x cube, the second term is x square, and the third term has to be x. But the x term is missing. We can assume there is 0x over there. So if I assume 0x is in the equation, the coefficient of x is 0. So if any term is missing, for that we have to write 0, and the constant term is just 1. And now what I have to do is I have to write the given root I over here. So now we can down this I over here. Now I have to multiply this I and I. So when I multiply I and I am getting I square. As I said already, the value of I square is -1. So when I is an imaginary number. So when I multiply this I and I am getting I square, which is equal to -1. I can write -1 over here. So now I have to combine them. There is 2 and -1. So when I add 2 and -1, I'm just getting +1. So now I have to multiply this 1 and the I over here. 1 times I is I. So when I combine this 0 and I, that is when I add 0 and I, I'm just getting I. So I times I will become I square. I square is -1. We get 0. So definitely we'll be getting 0 over here, because already we know that I is one of the roots of this equation. Since I is one of the roots of this cubic equation, so definitely we'll be getting 0 over here. Okay, now what I have to do is I have to write a new equation using these numbers as coefficients. So and the degree of the new equation will be 1 less than the degree of the original equation. So here the degree of the original equation is 3. Then the new equation that I'm going to write will be 2, which is 1 less than the degree of the original equation 3. So there is a new equation that I'm going to write will be a quadratic equation, because it has degree 2. So for that, what I have to do is I have to take the first number over here, I. This I should be taken as a coefficient of x square. Then I am getting I x square. And this 1 should be taken as this positive 1 should be taken as coefficient of x, that is positive. 1 times x is just x, positive, and this I should be taken, this is a constant term, it is equal to 0. Okay, now the given cubic equation has been reduced to quadratic equation, so using the given root and also the synthetic division. So now what I have to do is I have to solve this quadratic equation. Since the degree of this quadratic equation is 2, like if I solve this one, I'll be getting 2 roots. So I have to find the 2 roots, the remaining 2 roots of the given cubic equation. Okay, now let's solve this. Let's try to solve this quadratic equation by factoring. So whenever I want to solve a quadratic equation by factoring, so the quadratic equation has to be in standard form. That is ax square positive bx positive c equals to 0. Yes, it's in standard form, because we have everything on the left side, and the right side we have 0. Okay, now to solve this quadratic equation, I have to multiply this constant term positive I by the coefficient of x square, that is I. When I multiply this positive I by this I, I'm getting I square. All of I square is -1. Okay, now what I have to do is I have to get 2 factors for this -1, so that the product of 2 factors equals to -1, and the sum of the 2 factors must be equal to the coefficient of x. In this case, it's +1. So I don't think we'll be able to get such 2 factors. It is the addition of 2 factors equals to +1, which is the coefficient of x. So the factoring method will not work to solve this quadratic equation. So now what we have to do is we have to use quadratic formula. So for that, what I have to do is I have to compare this quadratic equation with ax square positive bx positive c equals to 0. When I do such comparison, I'm getting a equals to I. So that's a coefficient of x square, and b is a coefficient of x. In our equation, the coefficient of x is a +1, or simply we can write 1, and c is a constant term. Here we have I. Okay, now let me write the quadratic formula over here. On second, x equals to -b positive or negative square root of b square -4ac over 2a. So I have written the quadratic formula. Now let me plug in the values over here. Negative, the value of b in our equation is just 1. Positive or negative, b square means it's 1 square, -4 times the value of a is I, the value of c is also I over 2a, that means 2 times I. So then we get x equals to -1, positive or negative square root of 1 square -4 times. When I multiply this I and I, we are getting I square over 2i. So x equals to negative 1, positive or negative, square root of 1 square is just 1, negative 4 times the value of this I square is negative 1 over 2i. Okay, so now let me continue on the next page. So we get x equals to negative 1, positive or negative, square root of, so we have 1, and when I multiply this negative and negative, it will become positive 4. So then I'm getting 1 positive 4. In denominator, we have 2i. So we get x equals to negative 1, positive or negative, square root of 5 over 2i. Okay, usually when I solve this kind of equations, if I get I in denominator, we should get rid of I in denominator. So how can I get rid of this I in denominator? For that, I have to multiply both numerator and denominator of this fraction by I. So when I do so, I'm getting negative 1 positive or negative square root of 5 times I over 2i times I will become 2i square. Let me write it. Okay, x equals to negative 1 positive negative square root of 5 times I over 2 times the value of I square is just negative 1. We can plug in negative 1 for I square over here. Then I'm getting x equals to negative 1 positive negative square root of 5 times I over, so 2 times negative 1 is negative 2. So now we can split up. So actually we have two solutions over here, because one solution is has to be done for positive sign over here, and the other solution has to be done for the negative sign over here. So we can split up this one into two solutions. So let me write it. X equals to negative 1 positive square root of 5 times I over negative 2. The other solution is x equals to negative 1 negative square root of 5 times I over negative 2. Okay, so I just split up this one into two solutions. So then we get x equals to, this negative sign can be moved to the top, and the same thing we can do in the other root as well. So then I'm getting negative of negative 1 positive square root of 5 times I over 2. And here x equals to negative of negative 1 negative square root of 5 times I over 2, just 2. Okay, now what we can do is we can distribute this negative sign to this and this. When I distribute this negative sign to this negative one, it will become positive 1. When I distribute this negative sign to this positive, it will become negative square root of 5 times I, or we can write over 2 times I over here. And here the same thing. When I distribute this negative sign to this negative one and negative square root of 5, I'll be getting 1 positive square root of 5 over 2i. Okay, so for the given cubic equation, already we know that I is one of the roots, and we'll have two more roots, because usually a cubic equation will have three roots because its degree is 3. So one of the roots is given, that is I. So now I got the remaining two roots, that the remaining two roots are over here.